So thank you for coming today to the 32nd Western Colorado Community Forest Conference. I am Kamie Long with the State Forest Service. I hope you enjoy the conference being here. Last year we were in Montrose, the year before we were here. Our first presenter, Mel Schreiner, the one and only Mel Schreiner. So Mel is our local CSU Extension Tri-River area entomologist who serves really the whole state. But she's a rock star.
Perfect. Thank you, Kamie. Well, welcome this morning. I'm going to start us off with a pesticide review, kind of a 360-degree talk on pesticides. I think a lot of this background information, and hopefully all at once, I don't mean it to be overwhelming. I think it will be really informative. A good background for folks that have used pesticides in different modes of action for a long time. And at the end of the talk, I'll tie it into my insect update. So I'm going to be presenting on like European elm scale, ash bark beetle, emerald ash borer, if I can get to it, Japanese beetle, and I'll tie in some insecticide themes there as well. So it'll become relevant, but we're going to start just with introductions today. So I'm going to give a pesticide overview, and I'll cover these pests today. I want to go through what I do for my program first. As Kamie said, I work somewhat in the area of about 4 counties out here in Western Colorado. And insects don't stay in one subject matter or one county. They're causing a lot of issues or awaiting discovery in a lot of these areas of Western Colorado. So I mainly focus on agricultural pests. I do work some in the urban forestry space, but more minimally so. I support arborists probably more directly through CEU education in our Western Colorado Pest Management Workshop that happens every February locally for Western Colorado. But I'm mainly here to support commercial businesses. Occasionally, issues with invasive species or public health arise, and I'm brought in to help with some of those issues as well. I serve this area of Colorado, this awkward box on the western side of the state, but I'm the only staffed extension entomologist at Colorado State University. So I'm located out here for our cash crops like sweet corn and our tree fruit production, or fruit production in general, including wine, grapes. However, I serve the western region, that mustard colored area, pretty strongly. I try to show up for counties in this region. I'm not a statewide position or even a regional position, but staff have questions about things coming into extension offices, hospitals, breweries, seed producers. I mean, you name it. There's lots of folks with questions out there. I try to, obviously, it's my job to prioritize folks in this 4-county region, but I'm trying to support folks across the western region. I do so by providing arthropod identification. So whether you find something in a natural resources space, an agricultural space, an urban space, you can approach our program, and we have the skills often or the resources to connect you to folks that can identify what that arthropod is. So if there's a really weird thing that you have coming into the extension office, we're definitely an open door to you. Please show me that bug that you have found. Hey Mel, what's that bug? I get that every day, and I love it. I provide a lot of insect education in different spaces. So I mentor college students. I work with local school districts, museums to provide education. I'm also an illustrator, so I'm trying to incorporate my artwork into helping people become educated about insects. It's an overwhelming subject. And I think art, having visual aids really helps us to learn. But often I find myself spending time doing site surveys. We work very heavily with seed producers. There's lots of insects that are really fascinating to me personally that eat seeds. So this is a big native plant seed facility down in the Four Corners area. And also I do a lot of field biology and involving natural resources. So this is newer for our program. I've coupled with the Colorado Natural Heritage Program entomologists to aid them in their statewide insect survey for Colorado that has been funded in partnership with CPW. They're trying to track data across all counties in Colorado for insects. And so they're doing this. It's a huge initiative. Until about 2029, they'll be surveying arthropods in the state. So we're helping to bring folks out into these communities that have historically not been surveyed for insects, and we're gathering data and funneling that into a software that will be included in the statewide survey. And I'm involving college students to do this, training them to be safe in the field and to learn the prowess of being a field biologist. We need to involve students so that they care about arboriculture, or they care about natural resources, or they care about agriculture. So getting students out into the field has been a big focus of my program. But today I'm here to talk to you about, plants in the landscape, and mainly I'm gonna start us off by, just introducing, there's a lot of insects that come to the state of Colorado for one reason or another. Some of those are problematic, and some insects that have always been here in the state become problematic as well. So, new bugs or bugs of focus, insects of focus, they could be native to Colorado, but they change in importance for some reason. So examples, Gambelophore, that's a native insect, but English oaks are, especially on the Front Range area, that they do get pretty heavily hammered occasionally by Gambelophore. Spruce hips, statewide issue. Poplar twig fly is also something, it's always been here, and it's behaving differently as we change the eras over, as time advances, things change. So, where do these new bugs come from? They may be native to North America, but they've expanded their geographic range to include a new state. Several examples of this, apple maggot, ash bark beetles, we'll discuss heavily. Walnut twig beetle the vectoring of thousand cankers disease. So how these regional relationships change can drive new flora, new fauna, in this case, to new areas. So, where do these new bugs come from? Most of the real problematic ones come from out of our country. They're an invasive species. So they're entering through a port state, often anthropogenically driven. People are moving plants, seeds, and insects around all the time with trade and commerce globally that is driving invasive species movement, and it's not going to go away. So I think it's critical to understand, most insects found on plants in the urban forest, focusing on what we're talking about today, are not native to the state. They have come from somewhere else, and because they're entering a new ecosystem, they probably have some advantage that allows them to outcompete something local that has priorly held that niche in that ecosystem, or agricultural ecosystem, or urban space. But just to define an invasive species, they're non-native to the ecosystem, and those introduction pathways are likely to cause some type of economic or environmental harm. So, when new bugs get into the state, there's a lot of things that can happen. They may never establish. They may establish, but prove to be, not very critical or important. So they may become naturalized, but they're not going to, maybe like the European praying mantids and the Chinese praying mantids you could include in this. They're predators. They're out there eating, but their populations stay in check. Our winters suppress their populations, but we consider them still beneficial, even in some cases, when they come from somewhere else and they establish, but they're not harming the environment. Maybe it's of a minor importance at first, and then they become important later, or they could be important for a few years and become less important. I mean, it's really, truly, there's so many examples of this that insects fall into these lanes. But they may establish permanently and become forever populations that we are managing and controlling in our state. So plant health care is a holistic approach. So it's really ecosystem management for the long term, and using tools, making decisions on how to consider how we can have healthy plants in our landscape, depending on our climate, our soils, our water. There's, a lot of cultural care that goes into this. So weather can be a massive component of this. And of course, looking at how we can utilize pesticides become really important. So I do want to talk about pesticides quite heavily in this talk today. I want to define it. It's really a product sold for the purpose of controlling a pest. Sometimes it's not even really a true chemical, but it's a product sold and labeled by EPA registration. And essentially, pesticides can control for different biology. So different insects, different plants, rodents, mites, public health issues like ectoparasites, you name it. We have a lot of common pesticide classes for this reason. We're going to be going through these today. So mainly talking about different insecticide products, but pesticides is the big umbrella word. It's all of the tools we have for controlling pests in the environment. We've got a lot of different categories. So whether you're trying to eliminate bacteria or mites or nematodes or algae, we have a group of products labeled for proper use and control of those pests. Okay. So, while there's risks with using pesticide use, we have tools in place like PPE. I think the culture still really needs to change on. I still run into a lot of folks that are like, yeah, it's fine. I mix all the time. I don't need my PPE on. And I don't like that mentality. I think it's really important to use pesticides, but I think you need to be considering your longevity as well. Any product you use, probably redundantly, it's really important that we consider how to mitigate risk and follow the law so that we're not endangering the environment or primarily ourselves as the applicator of that product. All pesticides have an EPA label. This is the Environmental Protection Agency, a federal branch of the United States government that regulates pesticide use federally. They provide label language that is associated with products. They're going to provide the name, the poisons that are active within that product, directions for use, everything from storing that product to applying it, to recommendations on how to keep wildlife safe. I mean, this truly is the law that you must follow as the applicator applying pesticides. So looking for those signal words indicating to your crews or to yourself, how dangerous is this product that I'm using? How can I damage the environment if I'm having issues? And then, of course, storage and disposal. So in the end, how are we gonna, ideally you're mixing to use everything that you're gonna use and you don't end up with extra, but every label comes with a registration number. And so, how are most presently insecticides discovered? Like, how are these present products, how do they originate? Many of them are derived from the natural world, from microbes, from bacteria, from fungus. I find that to be fascinating. So our microbial pesticides. There's several that are found, obviously, in flora, in plants worldwide, and several are derived from hormones used in insect growth. So there's a wide array of how lots of pesticides have come into play. Sorry for the wordy slides, but we've got to get through some of the background. Non-selective pesticides are broad spectrum products that are going to harm and kill a wide range of organisms, and that includes beneficial ones. So they're not going to say, when a product is applied, it's going to basically wipe out a large array of biology. So it could even impact things like pollinators and birds or other animals, for example. So I'd say, just common examples of, an herbicide would be glyphosate that kill many types of broadleaf weeds, and then, malathion, which is broadly used to kill insects. So these are not going to just target one group. They're going to target lots of groups. They have a wide array of impact versus products that are selective. They are going to their mode of action or mode of entry onto that pest is, designed to target that specific pest. There's some specific mechanism it's much more of a specific kill than a wide killing agent. Selective pesticides are used in situations where that target pest is known and the risk to that non-target organism is high. So I would use as examples are like BT products. So that is derived from bacteria, soil bacteria, which is really only going for certain groups. And they have different strains for different groups, but they're very selective even down to like insect order. It's important to note that selective pesticides are generally considered safer for the environment than non-selective, but they can still have unintended consequences. So it's really not black and white. Active ingredients are the poisons, the chemicals in a product that kill, control, or repel pests. And then you have your other ingredients, your carrier. often will be included as well. Some more definitions. So insecticides can be systemic or they can be non-systemic. And so when a pesticide is systemic, I kind of think of it as it's entering the whole system of the plant. It's capable of translocation within that plant. So it moves within plant cells and it has longer lasting effects for efficacy because it doesn't dissipate as quickly because it's entering the plant body. So systemic activity can, it's somewhat limited to a few modes of action, like our neonicotinoids and group 28, some of those ranitidine receptor products, they can have systemic activity. So when you spray a plant, it can move through layers of that plant and get aphids on the other side, for example. So it's going to move through that plant body, and primarily in the xylem is where we're going to see that happen, versus products that are just going to be surface coated. So you're going to spray that product. It's not going to penetrate that plant or that animal. It's going to remain on the surface. So non-systemic insecticides. So just to define some of these terms, we hear a lot, but I hope to just provide clarification by spelling them out in front of you. But insecticides enter pests in various ways. So maybe through contact, through touch, or through entering their open circulatory system through their spiracles. Insects don't take active breath like we do. They just have air passively diffusing into their cells. So we can have volatilized products enter insect bodies or pests through that mode of entry. And they can also ingest products as well. We're eating plants that have been sprayed with products. So pesticides, can be selective due to just mode of entry alone. So for example, insecticidal soaps, I don't really recommend using these too heavily unless you've really tested them on a small batch of plants first. But soaps and oils can be applied on the body of a target pest and there's no persistence. And BT, for example, that can be sprayed and it can touch the caterpillar, but if that caterpillar doesn't eat a plant that has BT sprayed on it and get the bacteria into its gut, it's not going to die. So there's specific things that maybe even behaviorally insects or pests have to do in order to have that chemical enter their system, often through ingestion, is what I'm hinting at here. But, common insecticide tricks, we're going to do a deep dive on this today, but I think it's, really critically important to realize some shut down nerves. Most of them are nerve poisons. Some of them are, of course, either, using possibly bacteria to attack the gut or some growth hormone disruption with insect growth regulators, and also the control or lack of control of muscle operation within the insect's body. So there's lots of ways that poisons can affect insects. Just wrapping up some on systemic insecticides. The common method of applying systemics are often through soil applications for root uptake, because we were talking about how systemic insecticides often enter the plant body through the xylem, and so by applying that through and watering appropriately that landscape plant or that tree, you're going to have root uptake of that product, and it's going to end up within the plant body. And when insects are feeding on that, they're going to be impacted by that poison. This is a really good way to apply products because you're not having to blast spray a tree. You're actually pretty selectively applying this, which I think is worth a mention. So one thing systemic insecticides do is they move through the plant. So translaminar movement. So systemic insecticides are the only insecticides capable of doing this type of movements where that insecticide is moving through the plant body. And can reach insects underneath of it. And of course, trunk injection is a common way that we apply systemic insecticides. These are several trade names here. And you can see here this really nice rainbow ecoscience diagram shows, you have to be very trained to inject trees and receive training from professionals, but the angle and obviously the size of the tree is accounted for. Then you're giving the tree a shot of product that's uptaken by the piping of that tree that is otherwise moving water. So that's why watering trees when we're applying products is so critically important. I can't emphasize that enough. Don't do this and then don't water the tree, right? One and one, they go together. Basal trunk sprays, this is also possible. Several products are still commonly used this way. That can still enter systemically through the xylem. Just a different action getting that product into the tree. So really, as I mentioned, whole tree sprays produce surface residues on all foliage. Natural enemies are killed, and the treatment area here comparatively is much more minimalized. You're not broad spraying the whole tree where there's lots of insects and fauna living in that tree. We're allowing in a different system using systemic products. We're having to spray less area, which can often be better for the environment. Preventative sprays are very common and necessary. However, despite some of the environmental considerations, we do have beetles that lay eggs at certain times of year on the outsides of trees, and we can preventatively spray trees to protect from those eggs hatching or being successful biology that start and then dig into that tree and become a problem. But I'd like to get through some of the groups here. So neem oil, you may have heard. Azadirachtin indica is the type of neem tree that we get neem oils from. And I think it's really important to realize the primary active ingredient is azadirachtin. So that's the poison that this neem tree creates. And it has several functions as an oil, but modes of action are various. They can be a feeding deterrent. I see folks overuse neem. I can see folks in greenhouses burn plants to the ground. It's definitely something to be considerate of. It's not something you can use all the time. And obviously we're always going back to following that label, make sure that we're applying in the right interval. There's really two main functions of neem. You can have the whole neem seed extract that includes all of the goodies, or you can have the neem oil, and then the other products are stripped out. And it's quite a ripoff, honestly. I think worldwide, most products on the shelf are the latter. They lack that active ingredient, azadirachtin. So whenever you're using a neem product, since you're becoming educated, you can learn that you can go to the active ingredients and see azadirachtin is listed as the active ingredient. If it just says neem oil, don't buy it. There's no poison in that. It's just going to act as a horticultural oil to smother. So be really critical on this one. That's mainly why I brought it up. But neem helps to target several big groups of insects. So I thought it was worth covering. The uses of neem does often, if you have azadirachtin in that product, it's going to disrupt insect growth. That's what that poison does. It interferes with the dysone and molting, and insects can't grow up. So it can be really helpful. Otherwise, if you just have neem oil and the poison has been stripped out, it's really just being applied like a horticultural oil. So it can work, but if your insect doesn't die by smothering, you're wasting time and product going out there doing that. So, leading us into horticultural oils, horticultural oils primarily act by, smothering arthropods, and they're used in a lot of instances, often for small insects or soft-bodied insects, hemipterous insects that suck the fluids, the phloems of plants, like aphids. But basically, it's like drowning in olive oil. You would be not able to, if you're a small little insect, you can't survive a big pool of oil that you are going to fall into just because the spray occurred. Sulfur is one of the oldest recorded pesticides, still actively used in a lot of our tree fruit industry. But its pesticidal uses are, it can be used as a fungicide. Primarily, that's how we see it used in, peach production. It can be a miticide, the activity against, several insects, like in potato production, but this is still really a common product considering how old sulfur is. It can be phytotoxic to plants. And then of course, here, I'm not sure why this guy is here. We're gonna skip it. I guess I'm talking more about, okay, we'll get there. But the translocation within a plant, you can see here, think of a dense canopy. There's going to be lots of aphids, and having the ability for your product to move throughout that canopy of leaves, it becomes really important. So it's a unique tool, and we've kind of reviewed this too. So But it's important that, applying systemic insecticides, I do want to get to this slide because it's important that you realize it can be a foliar spray. It's often a soil application. It could be a soil injection, a drench, in furrow at planting. It can be a seed treatment that those seeds are treated initially, or it could be a trunk injection. So there's lots of ways that these few groups of very important products are utilized. However, with systemic products, there's special risks because some of them are more mobile in water than others. So leaching into groundwater we've got to be very considerate of that. How is that insecticide going to move in our environment? And then, of course, the leaching of insecticides, into groundwater or into nectar sources through plants. Because if we are moving a product into the plant, if that plant has nectaries, we need to be aware that that product may or may not, probably more often it does move into the nectar. Often, at least in ash, there was a study done that I was related to, it doesn't end up in the pollen and ash doesn't have nectar. So ash is a tree we treat heavily with systemic products. However, we get kind of lucky that nectar is really not a big part of that tree's early season gain. But in general, I do want to take the time. Insecticides and pollinators, the bottom line is you want to do your due diligence to avoid applications to plants that are blooming. Spray at night, spray at dawn before they're out and about. Find a way to do what you can. You have to apply a product and there are blooming flowers. And it's not just for the good nature of your heart. I hope that you would consider that too, but it's actually now law federally. So EPA is now launching pollinator language and have so for the last year or so, listing, high hazard products for bees. And so this is the language that you can be looking for. It's federal law. So I do recommend following those rules and just being aware that what you do in the environment does have impacts. The prevalence of pesticides in ag and in urban streams globally all over our world is a fundamental concern for aquatic ecosystem health and for water quality. And these are things we hear a lot, but this is an important thing to always keep in mind. We're going to go through classes of insecticides now. We've got fluorinated hydrocarbons, some of the oldest. They were first widely used post-World War II. They are broad spectrum products, so they eliminate a lot of things in the environment, and very few are still labeled today. But they have a very, very long persistence in the environment. So they last in our soils for a very long time, like decades and decades. Some are still around that we sprayed in the 50s, etc. So maybe important that we consider how those products last for a long time. To get a little dark, I do want to talk about this because I think it's important history, but a lot of warfare drove initial research into insecticide production. So in 1930s Germany, there were scientists studying organophosphates and how they could be used as nerve agents to kill people. So I think that's really a little dark, but that is where some of that original research was founded. Post-World War II, there were scientists all over the world that adapted organophosphate research and chemistry for pesticides for other animals, insects primarily. And then things like DDT and other compounds that get a lot of attention were developed independently of warfare. But it's important that some of our earliest research on insecticides, we realize that's really some of the origin. They were repurposed for agriculture, but originally they were wartime chemistry. I don't think we should hide from that, but we should be aware. DDT, like I said, was independently introduced. It helped to stop epidemic typhus, to protect our troops. You can see here this individual getting it applied directly to his chest. Sheep, you name it. This was, it was gross looking through what photos to even put on here, just because there's children running in the street being sprayed with DDT all over Google. So just be aware that we've come a long way with regulation, but these products were fat soluble. They're staying in our fat bodies for a long time. They're persistent in the environment. They form dense non-aqueous phase liquids that stay persistent in groundwater. They can be concentrated in fat tissues of organisms, and then they biomagnify. So as something eats the zooplankton, and as the zooplankton is eaten by fish, and then something eats the fish, that ends up in our wildlife. So one of the first marine biologists to help introduce this concept and have us thinking differently about insecticides was Rachel Carson. So her book, Silent Spring, is very famous, talks about how, out where she was, year after year after these massive pesticide regimes were coming through the environment, she heard less and less wildlife, like physically. She couldn't hear, the animals out there anymore. But she got us rethinking on insecticide use, and it did launch research that studied how DDT was a problem, and it led to its banning in 1970s, which is crazy it took that long. But it was because they were able to prove, in ppm with data that it was thinning the shells of birds, it was impacting wildlife. So organophosphates, there's not very many of them around, and probably for good reason. The primary class of insecticides that were used in the 60s to the 90s, they were nerve agents. They have polluted several things. There are several still around. I think it's worth knowing we still have several of these. Chlorphos was taken away in 2021 and reinstated back in 2023. And people even fight. I mean, there's very few left that allow us to kill things broadly. Sometimes there's a time and a place for that. So dwindling down this list, I feel, is important just personally, but we do use these as tools. Like lanate, I would say, is one that's, common. I think it might be a carbamate, but it's an older chemistry that is still used in sweet corn production today, for example. There are lots of non-target effects with certain products as well, as we've covered. Wildlife can be impacted by some of the broad spectrum stuff. So, permethrin, this comes from daisies. This is one of our contact insecticides. This is the original form of this. So you may have heard something similar, pyrethroids, which we'll get to, but this is the original. This is where permethrin comes from, the Tanacetum daisy. Colorado used to be a huge producer of this plant, like right around Civil War times, and it was for insecticide use. So this is often the product that is taken and is labeled organic. But yeah, it can be made into an extract from a plant. And it's a botanically sourced insecticide. So, I think it's critical to just, tie those together. They took that plant compound and then they made a synthetic version of it. And those are our pyrethroids. So they're synthetic permethrins. So they're just a man-made version of that product, that chemical. And we use a lot of these. These are broad spectrum for the most times. If you're working with a trade name or mainly I should say, I guess trade names is good, but active ingredients as well. If they end in thrin, it's often a pyrethroid. That's a good little tip for you. But pyrethroids, they have relatively low toxicity to humans. I still would wear your appropriate amount of PPE. You can always wear more PPE, so but those non-target effects exist for pyrethroids. For our birds, it's relatively low. And for fish, it's extremely toxic. So having an awareness of some of that as you're applying is important. Pyrethroids are broad spectrum, often used for, tree sprays. I would say it's very common, or like ortho home defense, things around the home, perimeter sprays, windows, etc. I mean, people are using pyrethroids. They last a few weeks time, and then they have to be reapplied. Nicotine. Many of you may have heard of nicotine as a form of, where we got some insecticidal compounds. It's botanically sourced, like black leaf 40 was huge back in the day. I mean, my grandpa had some in the shed last summer. Okay, got to deal with this. But we made neonicotinoids from nicotine-derived products. This is an insecticide class that was commercially available in the late 1980s, and it's been used very heavily since. So it's one of our systemic active groups. So we can spray neonicotinoids, and they're going to end up in plant bodies, where we're hoping they end up, so that pests will feed on those plants and then die. Their mode of action is it's basically a receptor antagonist. You can learn more about it. It's I think it says 7A, but I wanted to say it was group 4, but I must have that wrong. Neonicotinoid uses tend to be effective against phloem feeding insects because that's where the poison ends up, is in the phloem. So insects, and when we know what aphids eat, like the phloem, the sugars, all those leaves are beautiful in the sun. They're photosynthesizing, obtaining glucose, and then that glucose, that photosynthate, is pumped around the plant where the plant needs it, and that's through the phloem channeling. Xylem is what's bringing water up from the ground, and phloem is piping all the sugars around. So if you know what insects are eating those sugars, like scales or whiteflies or aphids, plant bugs, you can have a lot of effects with, neonicotinoids. Not all neonicotinoids are the same. Some are a lot less stable in UV light. Most things degrade in UV light, by the way. You can put anything out for a year in the sun and it's going to fall apart, plastic especially. But water solubility, the rate of uptake, some plants will uptake that faster than others. The mobilization within the plant, how easy does it move within the plant? Is it fast? Is it slow? And then of course, the types of hosts that we use they'll have differences too. I really do want to point out that dinotefuran, which is a really commonly used one in our industry here, is very water soluble. It moves in water the best out of all of them. So have an awareness, especially with dinotefuran when you're applying it. It can end up in our groundwater. And then look at the UV comparison. I mean, there's lots of differences there. Some are much more easily going to break down in UV light, like clofazimide. I don't use that one very much, but neonicotinoids can trigger spider mite outbreaks. I get a lot of questions about this, and I wanted to talk about why. So treated plants can make mites reproduce faster. And that's because that plant, when it's been sprayed, it can weaken the plant's immune system. And that insecticide alters the plant defense chemicals. So you also have often predator loss when you've made a spray. So things that were eating those spider mites aren't eating those spider mites anymore. And the environment, obviously stress and heat and drought can worsen mite growth as well. They thrive on drought ridden plants. So just keep that in mind. It's mainly insect ecologists are studying this heavily now. It's the weakened defenses that really is allowing the spider mite populations to blow up. So just have an awareness of that. I am going to cover microbial insecticides. These are insecticides, bacteria, viruses, fungus that are derived from microbes. So Beauveria bassiana is a really famous one where spores of a fungus are released into the environment, and those spores end up landing on the insect, and then it takes over them like a zombie, pretty much. BT, we have to talk about BT. Bacillus thuringiensis is a soil bacteria, and like I mentioned earlier, we have several varieties of this bacterium that have been put into products and labeled for very specific use on beetle grubs or on mosquitoes or fungus gnats or dipterous insects or on Lepidoptera, our moths and our butterflies, a lot of these caterpillars. So we can use certain strains of bacteria to target certain insect groups, which is pretty profound. Abamectin, this is a soil-derived bacteria. It's where we get emamectin benzoate and milbectin. It's really critically important to realize this is coming from a bacteria. So is spinosad. If you've heard of group 5 products, these are also derived from soil bacteria and just a different variety. And the synthetic derivatives are the spinosids. So they've done something similar like with permethrin and pyrethroids here, where they've taken basically spinosad and they've made spinatoran. So they're making synthetic versions of these soil bacteria as well, just to be aware. If you're curious, IRAC, it's a really great organization, the Insecticide Resistant Action Coalition. They have a very dense website, hundreds of sheets on insecticide use. I can't recommend some of their literature enough, especially if you're using insecticides. If some of this was interesting to you, this is your website. Either way, I'd have IRAC on speed dial, I guess. I do want to move into talking more about an insect update. Thank you for bearing with me. I think a lot of that will tie into what I have to say next, but I'm going to start with some research that I've done on the European elm scale and resistance to neonicotinoids. So these systemic products that have been piped into trees for decades. What does that look like for resistance against those insecticides? And so we have European elm scale. This is a soft scale insect. You can see here all the little crawlers crawling around. And then the bigger females, they live on elm trees. This photo is taken on the CSU Oval. And, prior to about 1995, European elm scale was controlled only by spraying products, broad spraying trees. And these elm trees, and it was pretty profound how much product, how much money was going into this. And it was one of the first shade tree insects that we used imidacloprid on, like back in the day. This was one of the first systems that really models this, basal trunk spray or soil injection, soil drench system with a systemic product. So merit was used on elms, and the result was fantastic. I'm talking like global news. I mean, everyone started using it like wildfire. It started to spread across the industry. It was a huge tool. You didn't have to spray massive elm trees anymore. You could soil inject an elm. And very quickly that embraced that product and was killing European elm scale. And this was in the early 90s. Doesn't seem to like that. Okay. So you're asking, wow, 2 decades, Mel, that's a long time to pump one group of mode of action into trees. What's going to happen? And unfortunately, a lot of folks didn't think anything was going to happen. For a long time, it wasn't researched well. And Whitney Cranshaw, who I studied my master's with, was fascinated with this. He had a very interesting system on the CSU Oval. They have a big, beautiful circle of American elm trees. And he started to scratch his head and say, what? Why aren't these working anymore? Why do we still have European elm scale on our elms? We shouldn't. These are getting pumped with chemical. And so unfortunately, insecticide resistance does develop in any mode of action, even if it's slower. And you have an original population of insects, and there's a few, the dark ones, that are resistant. And as you spray, you knock back the population, and those resistant ones, they live. And then more and more, they're breeding within the population, ramping up their capacity to fight that chemical poison. They just become super bugs, simply put. And then you end up with populations of completely resistant pests. When we only have one group of systemic products, your hands are kind of tied. What are you going to use otherwise? So I can't exaggerate enough how critical it is to still rotate chemistry against, neonics, because we've redundantly used them, and now we're running into a lot of problems in arboriculture. It was a recipe for resistance, folks, really pumping all of these. One way that we kill insects into trees for over 20 years. Almost, every scale infested elm in the area of Colorado was pumped with neonics the last 2 decades. And it's been the poster child for how an insect can develop resistance in a shade tree. There is a paper we've authored on this. If you're curious, I'm not going to link the title. If you're wanting it, let me know. But I do want to just encourage you, some neonicotinoids used for woody plants are as such here. So imidacloprid is really common. Flufenanidan, I'm still messing that up. Dinotefuran. And if the resistance develops of one of these, they all work the same against the pest. The poison works the same. So it doesn't matter if you trade your trade names. That's not what you need to trade. You need to move out of using a neonicotinoid in general. So if resistance develops to one of these, an elm, for example, all of these insecticides no longer work. So I don't want to just leave you dark and gloomy. Please use other products for elm scale. There are other products you can use that are not in that mode of action. Neem, that's why I talked about neem at all today, because azadirachtin can be trunk injected, azosol, azagard, acephate, maybe lean more away from that one, but pyriproxyfen is a spray, and distance is probably the one I see used the most. But just keep in mind, there's a whole paper on resistance. If you're curious about that, I'm going to move on to the emerald ash borer, because we've had quite a year with this thing on the Front Range. It's moved and expanded to a few new counties. And of course, last year it hopped the divide and came over to Garfield County, so made a huge leap. But this is the emerald ash borer, native to China. No one really knew anything, mainly Asia, but big portions of China. The native range, really no one even knew about this pest. And it's really important that folks realize that once it moved elsewhere, that's when we started learning about it. When it was accidentally introduced to the US in the early 2000s in the Detroit area. So, it's very rare in its native range that it's even known to have been an issue. Its biology is, adults are, how they look, they're quite small, smaller than you would think. Bigger than, of course, a grain of rice, but it's not very many millimeters long. This beetle I'm always surprised how little they are when I end up seeing them. But they're about, 1 year for a life cycle, 2-year development, typically in newly established sites. But there's more rapid development in areas where we have urban ash forests, which is not in Colorado. So the East Coast is really, that's why this was like such a famous, profound issue, is because millions of trees are being deleted by this biology. It was a tree killer. That was the fate of those ash forests. But we only have urban pockets of a fraction of species of our true ash. And that's why we're all little islands, and humans are moving the beetles around to the different islands, and they just live on all these little islands. And so now Colorado's slowly becoming more infested. It's taken a long time for it to do so, but the damage that's done is by this larvae. They tunnel under the bark, they girdle the cambium, they cut off the tree from all that good water and nutrients we've been talking about today that they need to live. But it was first discovered really, in Michigan, as we covered. So, the symptoms of injury are mainly shown through canopy thinning. There's a whole scaled system where you can actually judge how thin or thick your canopy is, how complete that canopy is. And often when we see ash trees that are thinning, they've got some kind of biology going on. It may not be EAB, but it may be lilac ash borer, maybe ash bark beetle, right? Ash is a very pesty tree, so it's got a lot going on. This is the first photo. This is Whitney Cranshaw's photo. I promise I credit him at the end. A lot of this is because of him that we know all of this. But he took this photo of the first Colorado tree that was infested with emerald ash borer, and he looked at that and said, wow, we got it here. Somebody moved firewood from the East Coast to Boulder County in 2013. Whoops. This is the original infestation area in Boulder, right there at the University of Colorado. Very quickly, it spread out. They started tracking it. It somewhat remained in Boulder County for quite some time. But I want to talk about how in our state it's going to disperse, because I've told you we don't have native ash forests. Mainly wind-blown dispersal of adults. So these adults are going to be blown around. As Whitney so lovingly says it, butt heads that move wood containing developing stages are going to be how we spread EAB around. Burn it where you buy it. I like that. It's kind of a newer federal, term for this. Don't move firewood around. You're moving things with it. But, adults are flying around until they first establish in the tree. They land on a tree, adults start feeding, and they lay eggs. But it's notable in Colorado today. I mentioned Carbondale last year. They've been dealing with this huge leap across the Continental Divide. But in 25, we have had more aggressive expansion on the Front Range. So I'm talking Golden, Aurora, Edgewater, Berthoud, all have confirmed populations. I don't think I'm missing one. And if I am, I try to do my due diligence to cover myself. But please let me know either now or at the end of my talk or sometime today if I'm missing one, because I'm trying to get this up to date. But it will continue to spread across the South Platte drainage. But of course, there are treatments for EAB and for ash. If you have clients that have prized ash trees, they're having to, choose to treat that tree and protect it, likely with a trunk injection, a soil injection, a basal trunk spray that for several years can help protect our trees. So there's lots of control options here. Our neonicotinoids are our biggest group that we have for protecting us against this type of biology. We're going to move to bark beetles, another type of biology that I could have just spent my full hour talking to you about these guys, but they're a type of beetle. Bark beetles are a whole complex affecting many host species, but they do cause severe damage to many trees in our state. They're a big deal. You can see this main mother gallery is chewed. She lays her eggs and her babies radiate out and just create this really, I think, lovely pattern. But there's lots of common bark beetles in Colorado. We're going to talk about the ash bark beetle. This is a native insect that's starting to misbehave. Mainly in Western Colorado is where we see ash getting really nailed by ash bark beetle, especially in the crotches of certain branches. They really like that area. But many types of ash are affected. There's up to 2, I would argue even 3 generations per year in some of these temperate gradients, but they're using hormonal cues. The bark beetles are famous for this and saying, hey, this tastes real good. Come on over here. Let's eat this down together and then we'll move on. But they completely girdle the tree. You can see those mother galleries are really etched in well. But these tunnels do contain fungus that stain the wood deep brown. That can help indicate to you that you have an issue. Obviously, holes on the outside of the trunk or oozing sap or canopy thinning. These are signs and symptoms you've got a problem. Growing stress is huge. So I've been doing a trial at Book Cliff Middle School looking at, I don't know who designed this, I'm sorry if you happen to be here, but I don't think they are. I don't even know who planted all these ash at Book Cliff Middle School, but there was one host tree planted at this middle school, all ash, it's all against hot asphalt, and they're having irrigation issues. So, I mean, it's just like a complete nightmare, frankly, for these trees. But mainly, I do that. We've done a 3-year trial looking at Mectonite and Trans-Tech with Rainbow Ecoscience. CSU Extension has partnered with Tony Smith. This is just completed for my PhD work. This is one of the chapters I actually have done. There's a lot more to go. But we looked at, before the trial started, how damage was ranking in these trees. And year after year after year, we tracked damage with canopy ratings. And this is not published yet, but I plan to publish this. Compared to our control, we do see downward declines of damage. So meaning trees are showing less damage over time with, different rates of Trans-Tech and Mectonite. So I just, I did want to cover that. I randomly pulled these photos. So these are the same tree, just this side was taken before they were injected with products for multiple years. And these were how they fared afterwards. So there's give and take here. And I intentionally chose these photos to show you it doesn't heal the problem always, but in some cases, trees looked substantially better having these products pumped through their system for several years. I do want to thank Tony Smith. I hope she's enjoying retirement. I miss her every day. I really do. She injected all of these trees and sprayed even some basal trunk sprays in this trial. And we did evaluations for 3 years showing some of this work. But I probably have like 2 minutes, and I'm going to try to cover the Japanese beetle because you may want an update on that. Some of you locally know a lot about it. The Japanese beetle arrived in 2022, but originally in the US in 1916 for the World's Fair. Showed up, it radiated just like EAB did across that western east coast. They feed on hundreds of plants. They have favorites though, we'll get to that. They have this behavior where they congregate on plants and just murk them. They destroy them, they're eating them. This is a pheromone signaling, and it's also when that plant gets damaged, beetles can smell that as well. So they lay eggs in the soil that is moist. So mainly areas that have irrigated turf grass are going to be our problem spots. So parks, country clubs, golf courses. I have a lot of fruit growers. I've got a lot of folks that are worried about what's going to happen when this gets in our orchard. It's not really where they primarily will breed. I don't think it's going to be the perfect system for them. It's mainly Kentucky bluegrass, golf courses, etc. That is the problem ground for sure for this invasive species. Of course, certain stages are easier to target. Targeting adults that fly around and eat on hundreds of plants doesn't really make sense. So early stages of this pest are targeted by treating turf grass. The beetles caught this year, this is their range. So you can see this, peak flight really happens mid to late July in Grand Junction. So we have some of the best data that we've ever had looking at flight in Grand Junction. And we have multiple. Yeah. All right. I'm getting cut off, guys. If you want an update, let me know. Catch me at the break. Thank you.
Questions for Mel? Online folks can also chime in.
So the question was, with neonicotinoid insecticides, is it through the bloom that pollinators are impacted? And not necessarily. If that plant has extra floral nectaries that are not associated with blooms, that could be a source, but it's nectar. Often, of course, flowers have nectar. Right. So it's some of both. To repeat the question, the University of Boulder, Colorado is moving their, I think this is EAB treatments for a 4-year cycle when it's likely labeled for 2 or 3. I think in the next, they're working on a 3rd year. I've heard from at least the products that come from Rainbow Ecoscience, I know they're working on a 3rd year in that company. In my professional opinion, we got to try sometime to see how long lasting this can be. So I think I commend them for trying. The data is going to drive on if that's holding efficacy or not. Someone's got to try them, just to answer your question. I think we could be getting 3 years. I mean, at least from what I'm seeing in the trials I've been a part of with Rainbow products, I mean, saying a lot of very similar active ingredients. I do think it holds 3 years. I haven't dabbled with looking at 4th year data yet. And that's in Colorado. Oh, great. You're welcome.